Welcome to all of you. In this session, we are going to have one more program of 8051 microcontroller. The program is write an ALP to move a block of n bytes of data from source, that is 2000H, to destination, that is 2050H, using external RAM. Now, with respect to the program, we are making use of these registers DPTR to hold the external address of both source as well as the destination, because both source and destination are the external memories. So with respect to external memory, we need only the DPTR to point for that. Then R0 and R1 holds the destination address, which will be loaded to the DPTR during the looping operation. Then R2 to hold the count value, how many values we want to move from source to destination. So that's the count value that will be available in the register R2. Now let us get into the program. Now this is the first part of the program. Remaining will be have the continuation. So we'll start with org0000h and then move dptr comma hash 2000. So first the dptr will be loaded with the source memory location, that is 2000H, and then move R0 comma hash 50H and move R1 comma hash 20H. So this is the actual destination memory location, which will be temporarily stored in R1 as well as the R0. If we make a combination of R1 R0, then it will be 2050H. So that will be the destination memory. So temporarily it will be stored in the R0 and R1. Then move R2 comma hash 05H. So R2 holds the count value, that means how many values we want to move from source to destination, that will be over here. So here we are considering 5 values. Now which are mentioned in this particular color, so that's the looping operation that will be repeated execution is going to happen. Now move x a comma at dptr. So move x in the sense, so this x indicates we are using the external memory, so that's why move x is the instruction. So move x a comma at dptr, the memory location pointed by the DPTR, the value present in that will be moved to the accumulator. Now DPTR is pointing to the memory location 2000H. So the value present in the memory location 2000H will be moved to the accumulator. Now the value is available in the accumulator. From the source we have taken the data. We need to move that to the destination. So destination location is 2050H. That value needs to be loaded to the DPTR. Before loading that, we need to save the current data, that is the current value present in the DPTR to the stack. So that's why we are using push DPH, push DPL. The values of DPH and DPL are saved onto the stack, and now we are loading move DPH comma R1. R1 in the sense DPH will be loaded with 20 value. Then move DPL comma R0. R0 consists of 50. If you make a combination of DPH and DPL in the form of DPTR, then we are going to have the value 2050H, which will be indicating the location of the destination. Now move X at DPTR comma A. So A was having the value from the source location. Now we are moving that value to the destination memory location. Now increment DPTR. So first value has been moved. We need to take that to the second value. So now destination will be there in the DPTR. So that value has been incremented. Save back the value of DPTR back to R1 and R0. So it is required for next iteration. So that has been saved over here. And then whatever the source value that was stored onto the stack being retrieved here, pop DPL, pop DPH, and again increment the source location by 1. Then until all the 5 values are being completed, keep repeating. For that we need to use this instruction for verification. Decrement jump on no 0 R2 comma back. So it is going to decrement the R2 by 1, and then it is going to verify the content of R2 is equal to 0 or not. If it is not equal to 0, then it will go to the back option. That's the iteration, that's the loop. If it is equal to 0, it will come out and it will stop the execution. So let us make a consideration of the data. So we are going to make a consideration that total there are 5 data that we are moving. So with respect to that, the source location 2000 H up to 2004 H. So this is what the data available for us, that is 10, 20, 30, 40 and 50. And in the destination, the memory location starts from 2050 H up to 2054 H, and we don't know what is the data available. So I have just marked it with a dash. Let us go through the program and observe what happens in each iteration. So this indicates iteration 1, 2, 3, 4, 5. Since 5 values we are considering that will move from source to destination, so 5 iterations are being considered. If it is more than that or less than that, so that many iterations it is going to run. So move dptr comma hash 2000 H. So dptr will be loaded with the value 2000 H, and then R0 50 H, R0 with the 20 H. So R0 and R1 are storing temporary location for the destination as it was told before. In R2 the count value, so R2 is loaded with 05 H. Now move X a comma at dptr. So we are going to consider that in the memory 2000 H that is now being pointed by the dptr, the value 10 is available. Therefore, value present in the location pointed by the dptr has been moved to accumulator, and that value is equal to 10. So accumulator consists of the value 10. Now the dptr has to be loaded with the destination memory location. Therefore, present memory needs to be moved to the stack. So push dph and push dpl. Now move dph comma r1. So r1 consists of the value 20. Therefore dph now will be loaded with the 20h. Now dpl, move dpl comma r0. So dpl will be loaded with the value 50h. Now total dptr, if we consider it now consists of the value 2050h. Now that is the address of the destination. Move x at dptr comma a. The value present in the accumulator will be moved to the memory location pointed by the dptr, and that memory location is nothing but 2050h. So the value 10 will be moved to this memory location. Now increment dptr, the destination location has been incremented, and move this value 2051h back to the registers R1 and R0. So move R1 comma dph. So that is R1 now will be loaded with the value 20h. Move R0 comma dpl. R0 will be loaded with the value 51h. Now the source memory location which was stored to the stack, we are going to retrieve that. So pop dpl, dpl will be loaded with the value 00h. Pop dph, that is dph with the value 20h. Now increment, this is nothing but the source location, increment it. So increment dptr, so now 2001h. Then djnz r2 comma back. So decrement r2 by 1. So now r2 becomes equal to 4. It is not equal to 0. Therefore, the loop will go back here for repeated execution. So this is the second iteration, as you can observe. Right? So starting instruction that are represented in the black color, so they are all one-time execution, and remaining is that is in the another color, so that is repeated execution. Right? So in the second iteration, so move x a comma at dptr. So as I told you before, in the source memory location the values stored are 10, 20, then 30, 40 and 50. Therefore the second value I am going to consider it's the value 20 that is available in the source memory location that will be moved to the accumulator. Then same procedure now keep repeating, right? So at the end, now R2 has decremented by 1. It was previously 4. Now it has gone to 3. Still it is not equal to 0. So it will move to the third iteration. Now let us see the third iteration. So this is the third iteration. Procedurally again the same. The value at the source now it is 30 as we considered. Then DPH, DPL changes you can observe over here. And now R2 still not equal to 0. It has decremented by 1. So now it is equal to 2. Move to the next iteration. Now same procedure has been repeated. Still R2 is not equal to 0. Now when it comes to the final iteration, after completion of this execution, R2 has become equal to 0. Then the program exits from this execution. So you have to make an observation over here. So as per the programming procedure, so now the DPTR will be, by default it has a incrementing, so 2055, no values to be transferred in that location. So similarly, so in the DPTR at the source 2005, so no values are there for the purpose of transmitting from source to destination, but procedurally by default they are going to get incremented. Since R2 becomes equal to 0, there will be no more iterations remaining. It will exit from the execution of this one. Now let us go through the program in the Keel software. After the completion of execution, so this is what we are supposed to get in the source location as well as in the destination. So in the 2000 to 2004H, so we are going to feed the data 10, 20, 30, 40 and 50 that has been fed. Any data can be put over there. So after the completion of execution at the destination, which was previously empty, we considered are some random value that may be present. Now the value will be 10, 20, 30, 40 and 50 in the respective memory locations. Now the program has been typed over here, same program. So let us get into the simulation part. First build the program, no errors. So get into the execution part. Now we do require two memories. So one memory is over here, memory 1. So let us make a rearrangement of this one. So here the two memories. So this is, I'm going to consider the memory 1 as the source and memory 2 as the destination part. Since this is the external memory, I need to write it as x colon 2000h. So that's the source location and destination is 2050. So x colon 2050h I will be taking. So before execution, I will load the values. So values I'm going to take it as, so 10h, then 20h, 30h, 40h and 50h. So all five values are initially loaded to the source memory location. Now let us start with the execution. So as the execution proceeds, so do observe the changes in the registers as well as in the accumulator. So first we are loading the 2000 value 2000 to the DPTR. So that DPTR is over here. So initially it is now equal to 0. Let us observe the changes. So now DPTR is loaded with 2000 and then R0 is loaded with the value 50, R1 with 20. So combination of R0 and R1 is what the destination location 2050H we are going to get. So then the count value, that is R2, is loaded with the value 5. So the value from the location pointed by the DPTR has been moved to the accumulator, that is the value 10. Now we need to push the value DPH and DP L to the stack, that is using push instruction. So as you can observe, the changes in the stack pointer memory location. So now the destination location is need to be loaded to the DPH and DPL, that is from R1 and R0, that has been loaded. Now as you can observe, the DPTR is now pointing to 2050. Move the data from accumulator to the destination. So as you can observe over here, the value has been moved to the destination location in the memory 2, that is value 10 to the location 2050. Now increment the DPTR, that is destination memory location, and then move it back to R0 and R1. Then retrieve the source memory location from the stack. Then increment the source location, decrement the count value. It is not equal to 0, so it is still equal to 4. So keep repeating the loop until all the values has moved to the destination. So you can observe the movement of the data in the memory 2. The last value is being now moved to the destination. So now the R0, R2 will become equal to 0. So execution will end. Thanks for watching.